Okay, hello there. Yeah, so we've been doing most of our work up to this point with the step wedge, and we made very small use of the Rompus block. Well, we've been doing most of our work with these two blocks. The half-inch thick fast block, which has 4 side drill holes at 100 thousandths deep, 100, 200, 300, 400. It also has a couple of OD notches, a 50 thousandths deep notch and a 100 thousandths deep notch. And we've been using this 300 thick notch block, and that has these notches of 8 notches of the following depths: 10 thou, 10, 30, 60, 90, 100 thou, 120, 150, 180, and 210 thousandths deep. And these have been extremely useful for us. And I'm going to introduce now some other notched blocks that can be very useful also. I've made a lot of good use out of these. And instead of having the notches be perpendicular to the surface, they're at slight angles. And one block has the notches angled at 15 degrees, 25 degrees, 35, and 45 degrees. So it's a lot of different ways to look at notches when they're angled, which was very useful for us when we were talking about any type of angled planar flaw, especially like hook flaws in ERW pipe. Let's take a closer look at some of these. Alright, so a closer look at some of these angled notch blocks. Get a little bit more light on here. Here's a 45-degree angled notch block. You can see our notches under there. And I've got these cards made up to make it easier to see which way the notches are going. So I'd like to take a look at this and try to do some detection and sizing with a 45-degree and see what the effect of the slantedness, the angulation, what effect that has on things. So I'm going to recall my 45-degree cal. Let's see, File menu. Whoopsie, 2, 3, 4. Open. 45-degree open, 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 contents, recall. And I think I'm going to make that filled inside that instead of hollow or outline. That's in the display setup, I think. Outline, filled, go back 2 times. All right, let's have a look and see how this 45 looks. Recall the cal, check the cal. Let's see. 1 is near 1. 2 is near 2. 3 is near 3. There we go. 4 is near 4. We're going to be working with this 300 thick notch block, so I'll set my gain to the 300 deep side drill hole. And I want to bring that to approximately 50% screen height, and it's there, so I'll engage my reference dB. Let's see. Second function, reference dB. Okay. And so let's take a look at this notch block, and let's look at, let's see, 10, 30, 60. Let's look at this 60 thou deep angled notch. It's angled at 45 degrees. And gosh, that just looks tremendously loud. Tremendously loud. I don't really see a tip in that. Let's look at that same one from the other side. 10, 30, 60. And now I see 2 things. I see a loud corner trap signal, and I also see a tip signal. And that corner is not peaking up at 300 deep. Let's see if the corner on the perpendicular one of the 60, if that does peak up at 300 deep. Yeah. So that's another effect I wasn't planning to mention, but having them be angled, that can throw off your depth sizing to the depth to that corner. Because that's not peaking up exactly at 300 deep like most of those corners will. And also it's very difficult to say that there's a tip signal in there. Very difficult to say that. But when we look at it in the other direction, then we're going to have a definite tip signal in there. There's the corner and there's the tip. And let me change this picture so that we're looking at a picture the correct way as an ID. All right, so we're looking at this 60 thou notch, and when the sound is coming in this way, it's going to be two different distances to the corner and to the tip. That's why we can see them separately on the screen. There's one distance to the corner and a different distance to the tip. And that's the depth to the tip on the 60 thou notch is 240, so I'm pretty close. Let's go back and look at that from the other direction again. Hopefully this card is going to help. We're looking at the 60 thou notch. And we just see something that's gosh awfully loud. And the sound coming towards the 60, it pretty much picks up most of that whole thing at the same time. There's very little difference in time between the time to the, I don't know if I really want to call it a corner, because we're really reflecting off almost the entire thing. That's part of what makes it so loud. That's like looking at a back reflector with straight beam. Anyway, there's some pretty dramatic differences here in the way things look, depending on how they're slanted. And spending some time with all these angled blocks can be extremely instructive. But one of the main things to observe is that when it's leaning away from you, it's just loud as heck. When the flaw is leaning towards the transducer, like this, then you have an opportunity to pick up a corner and a separate tip, because they're two different distances away. So we could spend a whole lot of time with these, and if you ever get an opportunity to look at any angled notch blocks like this, it's a real eye-opener. You can really learn a lot. And you might, there's a section in the book here on how to make your own cal blocks. You could try to make some angled notches. Kind of difficult with a hacksaw, but it's worth the effort if you get a chance to do that. All right, thanks a lot. Bye for now.